Welcome to a new Voltlog. Today I'm going to be reviewing a web-based EDA suite called EasyEDA. So the guys from EasyEDA contacted me and asked if I could do this review. I accepted, and they're also going to be offering some free coupon codes for my viewers, which you can use to order PCBs, but more on that towards the end of this video. So let's start by taking a look at their website. We can see that being a cloud app, it's supported on every platform or operating system. You get schematic capture, circuit simulation, and PCB layout functionality. You can import files or projects created with other design tools like Eagle, KiCad, or Altium, and I'm sure it does most of the things that every other PCB design tool does. You can share and collaborate with other people on your projects, so that's a big selling point for EasyEDA, and they made sure to put that on their front page. I'm sure a bunch of other features are available and are not mentioned on the homepage. And best of all, you always get to work with the latest version because the app is on the server, not on your computer. Another good thing is that you have the whole process from design to finished PCB on one single app or service, and you just click through until you get the PCBs at your doorstep, and that's a very big advantage for some people. Now, big concern with this kind of web-based apps is what happens if they decide to shut down the service. Well, the guys from EasyEDA say that if they ever decide to shut down the service, they will open source the code and allow people to download all their projects. So in theory, you are covered. You could host your own server if that ever happens. So let's get started on reviewing this app. Registering an account is super easy, but I already have my account created, so I'm just going to log in. You could also log in with Google Plus or QQ. This is how the interface looks like. I don't have any projects created yet, but I'm going to go ahead and create a new project because during this review I will be making a PCB for a simple circuit. We can start normally with a schematic, or we can jump straight to the PCB design because there are some people who like to start directly with a PCB layout design. And I can understand there are designs where a schematic is not really needed, for example when laying out a big LED matrix. As you can see, we can move around these panels as we please, and I'm recording this video in 1280 by 720 resolution so that you can see better all the elements in this graphical interface. But you can get much more workspace if you use a higher resolution, as most people do. Here is the schematic I would like to create a PCB for. It's a light sensor that uses an LDR to detect low light condition and then trigger a relay which will apply power to anything you like, a light bulb in my case. I'm going to start by placing our components. Let's start with resistors. We can choose US or EU symbols. In this video I'm going to use the EU symbol. For rotating the components you can use the R or space key. This is a shortcut, and there are various other shortcuts that you can find by reading the manual of this application. I can change some settings for this component on the right side panel. For example, I've changed the value right now. I'm going to place multiple resistors through the schematic. I also need a potentiometer. Let's see where we can find that. There it is. It seems like information about the actual physical package is not yet visible or accessible. That might become available when I switch to the board layout tool, or it might be here but I'm not seeing it. I also need some capacitors, and I'm using the EU capacitor symbol as well. I will be needing a diode. Let's find the diode. Okay, I also need a bipolar transistor, an NPN one. I also need a relay and an op amp, which we need to search through the available public libraries. So I'm pressing the More Libraries button, and I'm searching for an LM358 Jelly Bean op-amp because I'm sure this part will be in the public libraries. I need the through-hole type, and I need to press clone, which will copy this public library into my own libraries, which I can then later use in my schematic. I'm also searching for a relay, and just a general purpose one. So it looks like for the relay I can just place the part in the schematic, while for the op-amp I had to clone that part into my own library first. I guess it depends on which library that part is located in. So now let's place our op-amp by going to My Parts, and we can see and place it from here. I'm a long time EagleCAD user, so I'm kind of used with the EagleCAD interface and way of doing things, where right click would rotate my part, while here right click just drops the selection. I also need a couple of pins for power that I'm going to place right now, and I'm going to place a US symbol resistor as my LDR just to make it look different. To change the value of a component, you need to select it, and then on the right side panel you have the value field that you can easily edit like I'm doing right now. Now that I have all the parts required, I can start wiring them. I'm going to start by creating this upper positive rail, nothing special, just a wire. The interface has been quite intuitive so far, most things are where you expect them to be. So I'm going to continue by wiring everything together according to the proposed schematic. Let's suppose that I will have some wire terminals on the output of the relay, but I'm not going to add them right now just to keep things simple. So everything is finished on the schematic side. I'm going to press Ctrl S to save my project, and this window pops up. I have the option of setting the project private or public, so you are not obliged to share your projects publicly as with that Altium web-based tool. So now if I press Ctrl S once again, I can save the schematic file. So now our project is clearly visible in the left side panel, and inside our project we can see our schematic file. We are now ready for switching to the board layout tool. We will probably need to do some changes regarding the physical package of these parts, but we'll see about that. For switching to board layout, we have this button right here. It's very intuitive with that PCB icon, and it looks like everything is okay. All the components are in through-hole packages, so that's what we wanted. Let's save this PCB file once again, hitting Ctrl S. Let's say we decide to make a change in the schematic at this point, and let's assume I want to change the package for the LDR resistor. After selecting the part, we have the package field in the right side panel, and after clicking the field, this window pops up, and it allows us to select through a variety of packages. And as we select through the different options, we can see how they look in our preview window, which is very nice. Let's go for this 7mm package for this resistor. After making the change, we need to save the schematic, so I'm going to hit Ctrl S for that. And if we switch to PCB layout, we notice our change didn't get pushed through. That's because the schematic and the PCB file are not in constant sync. For that, we have this option right here called Import Changes. So we see it detects our changes. I hit Apply Changes, and then it automatically ran a DRC for us. Now we can see the changes have been applied in our design. Another important feature of a PCB design is the ability to control the grid. And with EasyEDA, we can do that from the right side panel, and you have all the usual options that I'm sure you are familiar with. I'm just going to work with the standard settings for this project. In the layout window, we do get automatically a PCB outline on this pink layer, and you can edit that according to your specifications, or you can draw a new one. I'm going to start by moving my parts inside the board outline. This will not be a very good layout in the end. This video is not about good design practices, it's more about showing you how EasyEDA works and what it can do for you. So please don't criticize my layout, because that's not the point of this video. So now I'm going to hit W, which is the shortcut key for the wire tool, and I'm going to start connecting all my signals. Right now we are on the top layer and I can easily switch to the bottom layer. While routing a wire, if you hit the plus or minus key on the keyboard, you can increase or decrease the wire size. But it only works with the main keys of the keyboard, it doesn't work with the numerical pad. I'm going to fast forward during the layout and cut all the unnecessary stuff from the video, because it's boring to watch me route this simple PCB. One thing I don't like during layout is when I start routing a particular net, I'm not clearly seeing all the points where that net is connected, like I'm used to in Eagle with the highlight feature. Like, I want to see them highlighted so that I can easily spot all the points related to that net across the entire PCB and figure out the best way of connecting them. One thing I didn't follow in this layout is the rule about the track orientation when routing on a double layer PCB. It's good design practice to route the top tracks in one direction and the bottom ones in the opposite direction. That will give you good results. But in this case, with the simple PCB, it really doesn't matter, and I don't actually want to manufacture this PCB anyway. One thing every PCB tool should be able to do is to copper fill a certain area. So let's try to do that. And we have a special tool called the copper area, which will help us. You double click when you finish delimiting the area. One thing that I'm missing is a ground net to which this copper area can connect to and extend. So I need to go back to the schematic and add a ground symbol to a net. That will change the net name to ground. And now, after importing the changes into our PCB file, our copper fill is visible. Now that my design is complete, I'm going to try to create a copy of this PCB file. Let's see how we can do that. So it looks like from the left panel we can clone the file inside our project. And now I have two files. I want to try the autorouter function, and for that I need a new PCB file where I can rip up all the tracks, and there should be an option for that somewhere in here. There it is, it's called Unroute O. So after clicking the autorouter button, we get this option window with the usual options for an autorouter. Let's click OK and see how long it will take and how it will do it. And apparently not much for this simple design. It looks like it did a pretty good job for this simple circuit. It looks just okay. Another interesting tool for a PCB design suite is the 3D view of your design. And EasyEDA say they are working on that, and right now they only have the 2D option ready. So let's give that a try. You basically get a look and feel for the PCB without any of the components, which is kind of similar to a Gerber viewer. But I've been reading on their discussion forum, and it looks like this is just a milestone on their path to a full 3D view function. Now let's see, if I wanted to move forward with this design and order the PCBs, I'm going to hit the fabrication output button, and this page pops up where I can select various options for PCB fabrication, and we get an instant price calculation on the right side, which is nice. It looks like for this design, getting 5 pieces is going to cost us about $17. It looks like we can also get a laser stencil if we needed to. And from here on, you can just add this project to your cart and finalize the order, which I have to admit is quite straightforward process. It might be worth pushing some small projects through this service. It might save you some time, not to mention money, because you don't have to pay any license for this software. Now, going back in the design window, I can also export this project as a PDF artwork, which can be used to fabricate your own PCBs at home, and that's also a big plus for the DIY community. Another option is to generate a pick-and-place file that can be used later into production for assembling your PCB. We also have a tool for measuring distances, so let's give that one a try. Okay, so that works nice. And another useful feature is that you can add dimension arrows on your design like I'm doing here. Another tool this suite contains is the integrated Gerber viewer, and you can access that from the fabrication output window. It appears the Gerber files are generated somewhere in the background, and you can view them here. I don't see any option for downloading them, but there are a couple of options you can customize here, like the solder mask color, so you get a better approximation of how your PCB is going to look like. But as mentioned before, this is very similar to the 2D view that we saw before. And here is an option to export this as images, and a button which probably has the wrong name, Destroy Gerbers. They probably meant destroy Gerbers, which will probably delete them so that you can maybe regenerate the Gerber files after making some changes in the PCB layout. This Gerber viewer tool can also be used with external files, so you can upload, for example, your own Gerber files in a zip archive from a different project designed with whatever CAD tool you're using, and you just supply an archive and it will automatically extract and identify the layers if you follow the standard file names and extensions. Here is, for example, the Gerber files for dummy load PCB I designed a while back, and as you can see, it automatically identified everything. So this is quite a useful online Gerber viewer. Here are a couple of features I think would improve the value of EasyEDA. Number one on my list would be a 3D board view feature. I mean, there is nothing better than seeing your board in 3D before actually going into production. Having a 3D view can save you so much trouble because you can immediately spot problems. I think it's a delicate matter to get it right though, especially managing the 3D models for all the different parts. It would be nice if they would accept some well-known, maybe even free open source format for 3D models, so people could use some free external tool to create their 3D models. But if they manage to pull that off and make it work with the same simplicity as the rest of their product, it's going to be a great feature. As I mentioned earlier in the video, there is a discussion on their forum about this, and they say they are working on this feature and it's a work in progress. Number two, I haven't found the options, so I'm not 100% sure it doesn't already exist, but I would like to be able to download my Gerber files, maybe as a zip archive, because I just like to keep those in my personal archive on my computer. I can understand though that can be against their business model because it might drive customers away ordering PCBs from another service, and I do think they make money off the PCB fabrication service because the whole EasyEDA suite is offered for free. And here are some features I liked most about EasyEDA. Number one, the most important thing, the fact that it's free for commercial use and you don't need a license. I think that is a big plus these days. Number two, the fact that you can import existing designs from Altium, Eagle, KiCad, and I think a few other CAD tools. So you are not forced to start from zero with an existing design. You can actually import that design and continue your work in EasyEDA. Number three, the fact that you have a complete service from schematic to PCB layout to actual PCB fabrication and simulation in between. This will save some people a lot of time and hassle, especially for beginners. I remember when I ordered my first PCBs, it was tough generating the Gerbers and getting them right. I remember I had to exchange a dozen emails with the manufacturer because of various issues I was causing. Here, all that is taken care of by the integrated system, so there isn't much you can do wrong. Number 4, the fact that you can share design and libraries is also a big plus. It's very easy and time saving when you find your components on that shared library system. You don't have to design your own your own library for every component you use in your design. Number 5, although I didn't have the time to show it in this video, EasyEDA has nice collaboration features that could be useful in a couple of ways I can think of. First of all, multiple designers could work on the same project, and second, a beginner or intern, for example, could be supervised while working on a project by more advanced users. This video is supported by EasyEDA, and after exchanging a few emails with them, we thought it would be nice to offer some coupon codes through some sort of contest. So EasyEDA are offering 5 coupon codes, each worth $50, and these coupons can be used to order PCBs from their online service. This might be a good chance of getting your project up and running with some free PCBs. For entering the contest, I have created a Google Forms document. There is a link to that form in the description below. You will have to enter a full name, email address, and YouTube username. There are a couple of rules. Only one entry per user, and you must be subscribed to Voltlog's YouTube channel before entering the contest. Registration will be opened until Friday, August 12th, and the winners will be drawn using random.org and be announced in the next video uploaded. So good luck to everyone. I hope you enjoyed this review. Please stay subscribed to my channel, and I will see you next time.